Hello students, all of you are doing good, I hope, right? Okay, so today I am going to take the third class on rational number. What is our topic on rational number today? It is the mathematical operations, that is addition or subtraction or multiplication or division of two or more rational numbers. So the properties of that and how we do that, right? And the first class I have taken on rational number, that is what is rational number and few of its properties. And the second class was comparison between rational numbers, how to do the comparison. So detailed explanation with example that has been given in both of these videos. So if you are interested to look into these videos, please go through the link which is given under the description section of this YouTube video. Okay, so let's start the mathematical operations on rational number. So there are few properties. The first property, that is called closure property. Closure property. So here, just for your understanding, what I will give. So what we have explained, that P by Q, any rational number that you can express in the P by Q form, where both P and Q are integers and Q not equals to 0. That already you know, right? Now any natural number that also you can express in the form of P by Q. Let's say 5 is a natural number, 5 you can express in the form of 5 by 1. So all these things I have explained in my first class. So here for addition, subtraction, multiplication or division, for your understanding, I will mostly use natural number, right, or integer number. Few of the cases I also will use fraction, but most of the cases I will use the natural number or positive or negative integers, right, for your understanding. What is closure property? Closure property means if you add or subtract or multiply or divide two rational numbers, if the resultant, so if it returns the number that is also rational, then it is called closure property supported by that operation. That means, let's say 5 and 7, two natural numbers or the positive integers. So what is that? Result is 12. 12 is also natural number. 5 means 5 by 1. 5 means 5 by 1, 7 means 7 by 1, 12 means 12 by 1. So all these are rational numbers. So if we add two rational numbers, then it returns also rational numbers. That means it supports closure property. If I give fraction 3 by 5 plus 1 by 5, both are rational number, and which is 4 by 5. So addition supports closure property. That means addition of two rational numbers returns a rational number. Let's see for subtraction. 9 minus 5 equals to 4. 9 means 9 by 1, 5 means 5 by 1, 4 means 4 by 1. So basically if you subtract two rational numbers, it returns also rational number. Just check for with fraction. 5 by 7 minus 2 by 7 equals to 3 by 7. So it is rational, it is rational, it is also rational. So subtraction also supports rational closure property. See, 2 by 5 into 3 by 5. What is this? It means you need to multiply the numerators and denominators separately. So 2 into 3, 6, 5 5s are 25, 6 by 25. So 2 by 5 is a rational number, 3 by 5 is a rational number, 6 by 25 it is also a rational number. So that means multiply also supports closure property. Number D, division. 5 by 7, let's say 42, it's a rational number, divided by 7, it's a rational number, equals to 6. It's also a rational number. So division also supports closure property. Or if you do like this, 2 by 5 divided by 3 by 7. You know how does it do? Actually 2 by 5 into divided by 3 by 7 means 2 by 5 into, when you will change the sign, then you need to make the reciprocal of this. Reciprocal means flip the numerator and denominator. So 2 by 5 divided by 3 by 7 means 2 by 5 into 7 by 3. So it gives the result 14 by 15. So it is also rational number. So that means addition, subtraction, multiplication, division, all these mathematical operations supports closure property. What is closure property? Closure property means the mathematical operation returns, mathematical operation on of two rational numbers, also or more than two rational numbers, also returns a rational number. That means it supports closure property, right? Next property on mathematical operation, it is called commutativity. What is commutativity? Commutativity is nothing but the order of operations. What does it mean? Commutativity means order of numbers. So for addition, if I change the order, let's say if I say 7 plus 2 versus 2 plus 7, both are equal. So if I change the order, 7 first, 2 second, here 2 first, 7 second, it doesn't matter. So both the cases it returns the result 9. So if you change the order, there is no change in the result. So that suppose order, if you change the order of numbers, then if the result doesn't change, that means it supports commutativity. That means addition supports commutativity. That means addition supports commutativity. So for addition, let's say 2 plus 7 equals to 7 plus 2. Both for similarly for fraction also, half plus 1/3 plus 2/3 equals to 1, and 2/3 plus 1/3 equals to also 3 by 3, that is equals to 1. So addition supports commutativity. B, subtraction. Does it support? Let's see. 9 minus 2 equals to 7. We know. But if we change the order, 2 minus 9 equals to minus 7. That means 9 minus 2 not equals to 2 minus 9. That means it does not support commutativity. So addition supports commutativity, but subtraction does not support commutativity. Okay. Next is multiplication. 9 into 5 equals to 5 into 9. Both are rational numbers, 9 and 5. So if I change the order, it doesn't matter in multiplication. If you change the order, still it gives the same result. So 9 into 5, 45, 5 into 9, 45. That means it supports commutativity. Now for division. 42 divided by 6 equals to 7. But if I change the order, 6 by 42, what it is? 6 divided by 42, 6 by 42 equals to 6 1 is 6, 7, then 1/7. That means it does not support commutativity. That means commutativity, order of operation, if I change, then addition and multiplication it does not impact. It is not impacted. That means addition and multiplication supports commutativity. But subtraction and division, it does not support commutativity, because Commutative means order of number. If you change the order of numbers, the result should be same. But for subtraction and division, if you change the order of numbers, then the result gets changed. That means it does not support commutativity. Okay. Next property will come associativity. Associativity means if there are more than two numbers, then if you change the group of numbers, then the result is impacted or not. So change the group. So for more than two numbers. So for addition, let's say you have more than two numbers like this, 2 plus 7 plus 5 equals to 2 plus 12 equals to 14. And if I say 2 plus 7, here I am changing the group. Here it was 7 plus 5, 2 was alone. Here it is 2 plus 7, 5 is alone. So changing the group. So here also 9 plus 5 equals to 14. That means these two are same. That means it supports associativity. So if you change the order of group, change the group, then it doesn't matter for addition. It supports associativity. What happens with subtraction? So subtraction, you know, from commutativity, even for two numbers also, it does not support. Still I will show you. Let's say 7 minus 2 plus 3 equals to 7 minus 5, that is equals to 2. But if I say like this, 7 minus 2 plus 3, then it is 5 plus 3 equals to 8. That means it does not support associativity. So if you change the group, then it does not support. Subtraction does not support commutativity. Subtraction does not support associativity. For multiplication, what will happen? Let's say 5 into 3 into 2. So 5 into 6 equals to 30. Now 5 into 3 into 2 equals to also 3 5 3 is a 15, 15 into 2 30. That means these two are same. So multiplication also supports associativity. What about division? Division, same thing. Division and subtraction does not support commutativity for two numbers. The same thing will happen for associativity also. So for division, let's say 9 divided by 6 minus 3 equals to 9 divided by 3 equals to 3. Now if you change the order, 9 divided by 6 minus 3, that means 3 minus 3 equals to 0. 3 minus 3 equals to 0. So if you change the order for division, that is, it changes the result. That means it does not support associativity. So for more than two numbers, if you change the order or change the group, it does not impact the result of addition on multiplication. So therefore addition and multiplication supports associativity. But for subtraction and division, if you change the group of numbers, then the result gets changed. That means subtraction and multiplication does not support associativity. Okay, just couple of things. For multiplication of rational numbers, let's say 2 by 3 into 5 by 6 into 9 by 11, what will be the result? Just straight away you multiply all these numerators and then all the denominators. If you can cancel, then you can do 3 3s are 9 and 2 3s are 6. That means 3 5 1 15 and 3 and 11 33. Sorry, 3 3s are 1. That means it is 5 by 11. So basically A by B into C by D into P by Q equals to A C P by B D Q. You need to remember that. For any division, what you need to do, if the division is of two different fractions, those are also rational number. If you change from division to multiplication, that means you need to flip the numerator and denominator. You need to find out the you need to mention the reciprocal. 7 by 3. 2 by 5 divided by 3 by 7 equals to 2 by 5 into 7 by 3. You need to remember that. Okay, there are a few more things you need to understand. So these are the terms. If I give the example, then it is very easy to understand. These are the terms you need to remember, because in exam or in the classroom also, these terms will be used. Additive identity, additive inverse. If you don't understand, then you cannot recognize what it is, right? So additive identity means 0 is called additive identity. Why it is additive identity? Because if you add 0 with any rational number, it doesn't get changed. Nothing gets changed. Adding 0, you know already this thing. Just you don't know this term. Adding 0 or subtracting 0, adding 0 with one number, be it rational number or whatever it is so, or subtracting 0 from a rational number, it is actually, there is no change. That is why it is called additive identity. P by Q plus 0 equals to P by Q. Additive identity. Adding additive identity doesn't make any change to the rational number. Okay? Okay, so adding 0 to any rational number, there is no change. If I add 0 to a rational number remains same. Therefore, 0 is called additive identity. What is additive inverse? Additive inverse is you need to multiply the rational number with -1. That means if P by Q is the rational number, the additive inverse of P by Q is minus P by Q. So if one rational number is given and you are asked to find out the additive inverse, that means you need to multiply that rational number with -1. Let's say minus 3 by 5. If you are asked to find out the rational additive inverse of minus 3 by 5, that means you need to multiply minus 3 by 5 with -1. So minus into minus means plus, that you know already, right? Multiplication of two same numbers give positive, plus. So plus into plus, plus, minus into minus also plus. So minus 3 by 5 into -1 means 3 by 5. So additive inverse of minus 3 by 5 is 3 by 5. Similarly, additive inverse of 3 by 5 is minus 3 by 5. Okay. What is multiplicative identity? The way for addition or subtraction, adding or subtracting 0 to a rational number doesn't make any change to that number. Similarly, for multiplication also, if a rational number is given, let's say it is 2 by 5, and you multiply with 1 is called multiplication identity. 1 is called multiplicative identity. 0 is called additive identity. For addition and subtraction it is used. There is no change. And for multiplicative identity, it is 1, because if you multiply any rational number, any number with 1, the rational number remains same. 2 by 5 into 1 equals to 2 by 5. So 1 is called additive identity, multiplicative identity. 0 is called additive identity. Additive inverse is minus 1 multiply minus 1 to the given number, rational number. So that is additive inverse, and multiplicative inverse is called also reciprocal. What is multiplicative inverse? Multiplicative inverse means reciprocal of 2 by 5. 2 by 5, if it is asked to find out the reciprocal, then also it is 5 by 2. So flip the numerator and denominator. Or if you are asked to find out the multiplicative inverse, then also it is same. Reciprocal or multiplicative inverse, these two are same. So 2 by 5 multiplicative inverse of 2 by 5 is 5 by 2. Just flip the numerator and denominator. So these 4 terms you need to remember. Additive identity, for addition subtraction it is 0. Multiplicative identity, it is 1 for multiplication and division, both the cases. If you multiply with 1 or divide by 1, the number remains same. Additive inverse is you need to the negative number of the given rational number. Negative means you need to multiply the rational number with minus 1. So if the number is minus, then the rational number is the minus, then the additive inverse will be plus. Just the changing the sign. And multiplicative inverse is the reciprocal, right? So once again the summary, what we have learned in today's video. Closure property, that means addition and multiplication for two rational numbers, if you add or multiply, it returns also rational number. So it supports closure property. Whereas subtraction and division for two rational numbers, that is also supported. So closure property is supported by addition, subtraction, multiplication and division, all the cases. If you change the order of numbers, then there is no impact for addition or multiplication. Therefore, commutativity is supported by addition and multiplication. Whereas for subtraction and division, if you change the order, the result gets changed. So it is not supported. Commutativity is not supported by subtraction and division. Associativity, if you change the group, there is no impact for addition and multiplication, whereas there is change in result for subtraction and division. Therefore, it does not support. So associativity is supported only by addition and multiplication. Commutativity is supported only by addition and multiplication. But closure property is supported by for addition, multiplication, addition, subtraction, multiplication and division for all 4 mathematical operations for rational number, right? And if you like this video, just click on the like button. And if you are interested to get such video, because I will take more and more classes for all different chapters in class 8. So if you want to have such notification, please click on subscribe button. Okay, thank you.